Okay, this is 8th grade lesson 6.5. The objective today, students will solve right triangle problems and determine if three side lengths form a right triangle. The standards covered in this lesson are 8EE2, as well as 8G6, 7, and 8. The page numbers out of the hardcover book are pages 260 through 263, and out of the practice journal, pages 133 through 136. Today we're going to be working a lot with Pythagorean Theorem. So the key thing is we need to review the steps of the Pythagorean Theorem. So Pythagorean Theorem is, the formula is a squared plus b squared equals our c squared. Okay, remembering that a and b are the sides that make up the right triangle, or the right angle of our right triangle. Remember, this formula only works for right triangles. So on the one that I just marked on the left-hand side of the screen, I'm going to go ahead and plug in my information. So I have a squared, 6 squared, plus b squared, 9 squared. And yes, those could be reversed around, equals c squared. I don't know the c because that's the hypotenuse, or the longest side. Okay, so now I'm going to go ahead and simplify where I can. I can't add 6 plus 9 because they're not the same base numbers. So they have to have the same base in order to add the base numbers. So let's see, 6 squared is 36. Plus 9 squared is 81 equals c squared. So now when I go ahead and I add those together, 36 plus 81 gives me 117 equals c squared. Then to get that squared off of the c, because I just want to know what c is, I'm going to do the square root. So that cancels that out. So I need to do the square root of 117. So one way that it may be listed is they might actually give the square root of 117. So the square root of 117 is 10.8. Now, they may also use the method that we practiced in lesson 4, and that's where you do your breaking down of your square root, okay? Because I know some of you are getting advanced problems on your star because you're working at those upper levels, and you're probably seeing some of these and not understanding what's going on with those square roots that are sitting in there. So 117, if I were to break that down, well, let's see, 7 plus 1 plus 1 is 9. So I know 9 will go into this. If I take 117 divided by 9, it's going to give me 13. That's a prime number. 9 breaks down to 3 times 3. Remember in section 4 when we went through and we broke it down like this, and we said 3 times 3 times 13, and the pairs get to go on the outside. So the other method that they may do is they may also write this out as 3 to the square root of 13. Okay, so you have to understand that those are interchangeable. Sometimes they're going to have you give the decimal number. Sometimes they're just going to leave it as the square root of 117. They may do that also. They may just leave it as this. But most often, if it's a more advanced question, they're probably going to leave it in this method if they're going to leave it as a square root. They're not probably going to leave it as the square root of 117. They'll break it down. Okay, so that's just advancing, tying in things that we've done before. Okay, so let's go ahead and use the same concept to find a missing leg. Okay, so we have to remember that when we use that Pythagorean theorem, we have to plug in the information where it is in the formula. So here's my a and b. Remember, it makes up the right angle. Those are called the legs. So I know that a is 10, so 10 squared plus, I don't know b, so I'm just going to write x squared, equals my c side is 12 squared, okay? Now, some of you might go ahead and do 10 squared and then get rid of it, and I did notice that some of you prefer to just move it to the other side and then work. So I've noticed some of you, when you were working Pythagorean theorem, preferred to do this method. Instead of simplifying that to 100, you just went ahead and did minus 10 squared, which is perfectly fine. We can now simplify it over on the right side. So now I have x squared equals 12 squared is 144 minus 10 squared is 100. Okay, so now I've got x squared equals, or if you did it as an a or a b, that's okay, 44. So to get rid of our squared, we're going to have to do the square root to cancel that out. So I get the square root of 44. So if I were to leave it as a decimal, square root of 44 is 6.6 rounded. Okay, and if I'm going to write it out in what we practiced in lesson 4, Well, that would be 4 times 11, and 4 breaks down to 2 times 2, right? So underneath of the square root sign, I would have 2 times 2 times 11. There's a pair, so it's going to be a 2 on the outside. So the other way that it could have been written is 2, and then the square root of 11. So either of those are interchangeable. Does the 2 times the square root of 11 mean a whole lot to me? No. If I was going to have to find the perimeter, I would want to see that 6.6. And that's what we'll be working with, but I did want to take the opportunity to go over this concept because I know that I have seen some of you getting that on STAR. And so I wanted you to understand that, yes, sometimes we write our side lengths of things like here in Pythagorean Theorem with that square root simplified, okay? So we're going to be working Pythagorean Theorem, so make sure that you're comfortable with that, and we're going to apply it to some other concepts. Okay, I don't know why I have this little Google thing, but it's not going to go away, and we're just going to leave it. It won't go away, so we'll just work around it. So it says, applying Pythagorean Theorem, it says, find the perimeter of the figure, round your answer to the nearest tenth. So if I want to find the perimeter, I want to add together the outside. So I'm probably going to do a decimal answer here. So Pythagorean Theorem, a squared plus b squared. Here's my a and b. Okay, so 6 squared is 36, plus b squared, 13 squared, gives me 169. That leaves me with c squared. So 169 plus 36 gives me 205 equals c squared. And then to get rid of the squared, we're going to do the square root. So that's gone. So the square root of 205 gives me 14.3. Okay, so now if they wanted to know the perimeter, because we're extending on what we did back in the Pythagorean Theorem section, which I think was section 2 of this chapter, they want us to find the perimeter. So they're adding a step to something that we have previously learned. So now perimeter, we know how to do perimeter. It's your distance around the outside. So I've got 13 plus 6 plus 14.3. And I'm just going to go ahead and add those together. So 14.3 plus 6 is going to give me 20.3 plus 13 is going to give me 33.3. Units was centimeters. So that's my perimeter. Okay, so there's finding the perimeter using going through to find that missing side using Pythagorean Theorem. Okay, so here's the next one. Find the perimeter of this figure. Round your answer to the nearest tenth. So once again, we get to use decimals instead of that square root concept. So let's see, together, I know I need these broken down, but together this is 9. Just when I go to do my final perimeter, then this is 9. I need to find out the side length. So in order to do that, I see a right triangle right here. Okay, so I'm going to have to do that in order to find what this side length is. Okay, so a squared plus b squared are my two that make up the right angle. So these two. So a squared, 3 squared is 9, plus b squared, 8 squared is 64. That's going to give me c squared. Okay, so 9 plus 64 gives me 73. So I get c squared equals 73. And now to get rid of that squared, I'm going to do the square root to cancel that out. So the square root. Square root of 73 gives me 8.54, so 8.5. Okay, so to do the perimeter, this is also 8.5. I'm now going to add all 4 of these together. So 8.5 plus 8.5 plus 9 plus 9 gives me 35. Dimensions were meters. There's my perimeter. Okay, so they're tying in stuff that you previously learned. Perimeter back in 5th grade is when you, 4th grade probably is when you started doing perimeter. And then now understanding Pythagorean Theorem and how you could find a missing side in a situation like here where they gave us the height of the parallelogram, but then not the slant length. Okay, so I want you guys to try this one. Find the perimeter of the figure, round your answer to the nearest tenth. Okay, so what am I seeing? To get you started, this is what I'm seeing. Here's our right triangle. Correct? There's our right angle. And then we've got the bottom that is the hypotenuse. So if I were to like show that flipped around, it looks like this. A right angle and the hypotenuse, and you've got 4 and 4. Okay, I'm just turning that triangle to make it easier for you to see. So go ahead, pause your video, work your way through to find out what this missing length is, and then find the perimeter. Okay, remember, if you get a decimal number, go ahead and round your answer to the nearest tenth. Okay, so I just found out that when I rounded the 5.65, that rounds to 5.7. Okay, so now when I go through to find my perimeter, I've got 5.7 on each of these sides. So I could either add them individually or I can just take 5.7 times 4. And when I do that, I get 22.8 for my final answer. Dimensions were feet. Okay, so that's using Pythagorean theorem to go through and just advance on finding perimeter. Okay, so sometimes they're going to give us some figures where they're giving us a grid and a slant line and asking us to find the length of that slant. Now, you guys have worked with this where you've gone through and you've found the slope of a line. Today, what they're asking is they want to know the length of that line. How long is it? They don't want to know the slope of the line. They want to know the length of it. So remember back when we would count out slope, we would do something like this where we would connect our dots, making a right triangle. Well, we're going to go ahead and do that same concept. No, we're not going to find the slope, but we're going to use those dimensions on each side to find, using Pythagorean theorem, the length of that side. So here we've got 1, 2, 3, 4 boxes. And here we have 1, 2, 3, 4 boxes. This should look familiar because it was just the last one that we did, the same dimensions. Okay, so when we went through and we did a squared, 4 squared, plus b squared, 4 squared, equals c squared. Remember, we ended up with this together, giving us 32, because each of them were 16. Okay, so now when I go through to do that, I can go ahead and, what was that, 32, gave us 5.7. So this is about 5.7, whatever the units are. They didn't give us units, so we would just label it as units. Okay, so that's working off of a slant line. So when they're giving you that, they don't want to know the slope. They're asking you to find the length of that line using Pythagorean theorem. So let's try another one of those. So once again, we're going to connect making a right triangle because that's how we can use Pythagorean theorem. Okay, we can't sit there and kind of guesstimate what it is because it's cutting through corners. Okay, so now if we use our Pythagorean theorem, my right triangle, I've got 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6 on the bottom. Okay, so a squared, 4 squared, plus b squared, 6 squared, equals c squared. Okay, so 4 times 4 is 16, plus 6 times 6 is 36. That gives me c squared. 36 plus 16 gives me 52, equals my c squared. So to get rid of the squared, we do the square root. So we can leave our answer in a decimal, so we're just going to go ahead and punch in the square root of 52 on our calculator, and that's 7.2. So this would, D would be 7.2 units. It's just another format that they can go ahead and give you to work that Pythagorean theorem. Okay, so here's another thing where it's a little bit more advanced. So it says find the height of the firework, round your answer to the nearest tenth. So notice that we have a triangle there, it's a right triangle. In the end, we also have that when they measured this out, that it was 1.5 meters to the ground yet. So we're gonna have to add 1.5 to our final answer. Okay, so we have a squared plus b squared equals c squared. We're gonna be working with some really big numbers here. So let's see, I'll say this is A and this is B. So this is my C, my longest side. So a squared, I don't know, plus b squared is 300 squared equals c squared, which was 335. Okay, so when I go through to do this, 300 squared is going to give me 90,000. So I have a squared plus 90,000 equals, then 335 squared is 112,225. Big numbers. Okay, so now we want to get the a squared by itself, so we'll subtract. And some of you maybe did the minus 300 squared on the other side and then simplified it. We still end up doing the same steps, just in a different order. Okay, so now when I simplify this, I have a squared equals 22,225. So now to get rid of the squared, I'm going to do the square root to get rid of that. So the square root of 22,225, that's a lot of twos, gives me 149.08. So if we go to the nearest tenth, it'd be 149.1 for this. Now, they want to know the height of that firework, so I have to include all of this, including that 1.5. So I'm going to go ahead and add plus 1.5 to my answer, and it's going to give me 150.6 approximately. So that firework is 150.6 meters above the ground. Okay, so let's go ahead and try another one of those. Once again, it's just applying Pythagorean theorem to a real world situation. Okay, so last one, it says find the height of the kite, round your answer to the nearest tenth. So Pythagorean theorem, we're noticing that the height when he's holding up the kite, that's 1.4 meters from the ground. So we have to include that in the end because we want to know how far that kite is from the ground. So here's our A and our B. This is our C. So we don't know a squared plus b squared is 6 squared equals c squared is 15 squared. Okay, so a squared plus 6 squared is 36 equals 15 squared is 225. Okay, so now I'm going to go ahead and get rid of my 36 because I want to get a squared by itself. So subtract it. So now I have a squared equals 189. And to get rid of the squared, I have to do square root. This is usually the step sometimes people forget to do is that square root. Oops. And when I do that, I get 13.74. So 13.7 for this. They want to know the full height. So we're going to do 13.7 plus 1.4. And when I add that together, I get 15.1. And then I about wrote 4. And then meters. Final answer. So sometimes they're going to give you pictures where you can use Pythagorean theorem, but then you have to tie into, like here, the height above, they kind of left some distance off between something and the ground. So remembering that you need to add that in. So that's pretty much it for Pythagorean theorem. Key thing to remember is when you're solving Pythagorean theorem, it's a squared plus b squared equals c squared, where a and b make up the right side of your triangle and c is your longest side or your hypotenuse. Don't forget as you're simplifying and solving those that you have to remember to find a by itself or c by itself or whatever letter. Don't forget to do that square root of that number. Good luck with this.